Hello guys, welcome to my channel. In this playlist, we're going to cover machine learning from scratch. If you are an absolute beginner, this course is for you. We are going to cover everything in layman terms. Going on, you'll understand about machine learning algorithms from basics. In this video, I'm going to cover the introduction and what machine learning is and why we need machine learning. Moving on to introduction, knowing about algorithms is mandatory, but it's not sufficient at all. We'll be covering machine learning algorithms from scratch, but as a beginners, you might think this alone is sufficient, but it's really not. You have to understand how to develop an end-to-end machine learning project. For that, we need to have mathematical foundation, how the algorithms are working, and also the flow of machine learning modeling, that is the data cleaning to perform imputations and pre-processing techniques. EDA is nothing but exploratory data analysis and model selections, many other topics like basic variance trade-off. If you don't understand any of these topics right now, do not worry, I'm going to cover every bit of it. So today we are going to start with our first topic. What is machine learning? Machine learning is part of artificial intelligence which focus on learning from data without hard coding using any statistical techniques. Now here I have used the term hard coding. What is hard coding? For every scenario, we write a code, that is, we tell the machine how to handle it. For example, I have scenario 1, 2 and 3, so on. Now I'll hard code it. I'll tell if the scenario is 1, return, it means the output from the code should be A, B, C, for example. If it's scenario 2, let it be A, S, D. If it's scenario 3, it should be F, G, H. Okay, this is how hard coding is. But in case of machine learning, we do not have to do that. What you do is, you got some data, you got an algorithm, you tell the algorithm to explore the data, identify the patterns between the input and output. And next time when you give a scenario 4, it will automatically tell you what could be the output. For example, it can be B and M, anything. And if you give S3, it will give F, G, H as the output without any of the scenarios being hard coded. That is machine learning for you. For better understanding, look at this flowchart. It shows difference between the traditional programming, that is hard coding, and the machine learning. So in traditional programming, you give data and also the program to the computer and it will give you the output. But in case of machine learning, you give the computer the data and the output, it will give you the program. For example, if you consider simple mathematical problem, that is addition. Let's say I have given the input as 1 and 2. Now I'll tell the program you have to add these numbers, that is, you have to perform addition x plus y and return it. That is, I'll say the input will be x when x is equal to 1, y is equal to 2. You have to return x plus y. That is, the output returned is 3. But in case of machine learning, what you do is you give a bunch of data. For example, I have given only like one data point, but you give 50 to 100 data points, this minimum. You give, let's say data point 1 will be 1 comma 2, the output is 3, and 2 comma 3, the output is 5, 5 comma 8, 13, 2 comma 8, 10, so on. You'll assume you have 50 records. Now you give all this data to the computer. Here 1 comma 2 is the data and you're also giving the output, that is 3, 5, 13 and 10. Now let's say these are the feature columns. There's the feature 1, feature 2 and this is the output. Let's say it as y. Generally we say x1, x2, x3, so on and y, but as I've already used x comma y here, I'm just taking f1 and f2. So what does machine learning do here? It will identify the patterns between f1, f2 with the output column y, and it will say I have identified the pattern between the data and the output, and the program is the addition x plus y. Now the next time when you give it 4 comma 5, it will say the output is 9. Here we do not have anything explicitly coded like written x plus y. Now let's increase the complexity of the problem. It's not addition now. Let's say now you have an experiment M1. Now this experiment will take 7 hours to perform, and it will also consume some resources. Let's say it will take 7 hours of time and rupees P amount of resources to run the experiment. Now I'll say the input is 1 comma 2 and the output is 7. And when I give 6 comma 7, let's say output is 2, 8 comma 9, the output is 4, and so on. Okay, every time you perform an experiment M1 on 1 comma 2, the output is 7. When you perform it on 6 comma 7, it's 2. So every time you are performing it, you're spending 7 hours of your time and P amount of money, right? Now I'll give this data to the machine learning model. I'll say I'm sending 1 comma 2 comma 7. Sorry, here I'll have to send the output as well. 1 comma 2 comma 7, 6 comma 7 comma 2, 8 comma 9 comma 4, so on 50 records. I'll be sending it to the machine learning model. Now it will identify the patterns between 1 comma 2 with 7, 6 comma 7 with 2, and it will say maybe the program which the experiment is using is M1. It will not be very precise all the time. The accuracy is not always 100%. But we train the model to get the utmost accuracy. We will come up with a best performing model. Okay, it need not be 100% accurate in real life. Now the next time I say the inputs are 2 comma 4 and I give this to the machine learning model, ML model. Now it will give the output as 3. Imagine you have done the experiment 2 comma 4 and the output is 3, correct, which is correct. Now when I give, this has not been given into the model for training. Now assume 2 comma 4 is a very new data for the machine learning model. Okay, now when you give 2 comma 4, if this pattern whatever it has recognized has given output as 3, it's correct, right? Sometimes it might give 2.9, 2.8, 3.2, so on, so which is almost near to 3. Sometimes it can also give very bad results, maybe 7 or so on. So that's why we say these are not 100% accurate. But so when you're giving it to the machine learning model and you're getting the result as 3, what does it mean? You're getting it first, you're getting it in seconds or minutes. You're not spending 7 hours of time, P amount of money to conduct the experiment. So indeed, you are saving both time and resources. So that is why we need machine learning models. We can save a lot of time and resources. Comment below some of the use cases in your mind. We can go through them and maybe we can pick one of it and try a hands-on. If we can get the data online, for sure. So moving on to the next videos, I want you to be familiar with Google Colab, or at least install Anaconda or Python. Also be familiar with Python or any other coding language, also fine, because Python is very simple to understand. I'll also be sharing few posts on Python basic coding, so that should be helpful for you if you do not know how to code in Python. And also I'm expecting some basic understandings of mathematical concepts like linear algebra and probability, because once we dive into how machine learning models are working and what's the basic mathematical funda behind it, you might need to have the basics of linear algebra and probability to understand it completely. So that's all for the day. Thank you. So please like, share and subscribe if you like the video.